Good morning to you. Yes, so good morning everyone. This is 11:53 Nigerian time, and I welcome you all to my channel once again. I remain your science teacher, Mr. Austin. In this class, or rather in my channels, we try to break down some of the topics in sciences, and in today's class we are going into chemistry, particularly organic chemistry. For those in chemistry classes, you might often be coming across structures of carbon and hydrogen linking each other and be told that this compound is named this or that. It keeps you wondering where these names are coming from. How can I be able to memorize all those names? How am I going to identify which one from which one? But sit down, relax. In today's class, we are going to look into the detailed process of naming these organic compounds. This class is divided into parts. As you can see in this one, we have it as part 1. The reason for doing this is for us to be able to capture as much as we could in terms of naming an organic compounds. So sit back, relax, and get some writing materials ready. I promise you won't regret the class. Now, before we go into the naming of organic compounds proper, let us look at the nature of organic compounds. Organic compounds are compounds that contains majorly hydrogen, and in some cases it can contain other elements like nitrogen, oxygen, etc., etc. And carbon is also the central atom in organic compounds, and it is the basis for naming an organic compound. That is to say that the number of carbon that is present in an organic compound determines the name of that compound. The simplest of these compounds is methane. You can see the structure of methane on the slide with 1 carbon at the center surrounded with 4 hydrogens. The question here should be, one could be thinking, why is carbon this influential in organic compounds? Why do we give carbon this attention in naming of an organic compound? Now let us look at the nature of organic compound and see for ourselves why carbon is this important or influential. Well, carbon has 4 valence electrons. That gives the reason for carbon being bonded by 4 hydrogen, as seen in methane. Carbon of all elements have the ability to bond with itself to form a long chain. This gives carbon the ability to elongate. That is, elongation means forming a long chain. So the ability of carbon to bond with itself gives it the ability to elongate, forming series of compounds depending on the number of carbon atom that is bonded together to form the compounds. This phenomenon, that is the formation of bonds or the formation of compounds by bonding carbon with carbon, is called catenation. To learn more about catenation, check the link on the comment section after this video to see my presentation on catenation. This structure, that is the structures we have here, we have like 3, 4, 5 structures here, but we have 3 names but 5 structures. So these structures here shows how carbon can bond with itself. It could come as a straight line, like the first one we have 4 carbons bonded in a straight line. It could also come as a branch chain, like you can see the branch there, dependent. You can call it branch or dependent, or cruise chain. You have 3 examples of cruise chain. We have the one that is, you can see the examples yourself. So these are the 3 ways by which carbon can bond with itself. Now, in the representation of these compounds, there are different ways to represent these molecules in organic compounds. The first is using the molecular formula. Here, the number of each element is indicated with a number of the elements. That is, in this case, we have C3H8. That is to tell you that carbon, which is the C, we have 3 carbons here, and we have 8 hydrogens attached to that 3 carbons. So it's just like a summary, a brief summary to tell you that in this compound, all we have here is 3 carbons, and all we have here is 8 hydrogens. That is the first way or the of representing or presenting those compounds. The second is using the structural formula. As can be seen, each element is seen bonded with each other. Let's take a look at the carbon number 1. You can see that carbon number 1 is bonded with 3 hydrogens and 1 carbon, that is carbon number 2. Carbon number 2 on itself bonds with 2 carbons and 2 hydrogens. Then carbon number 3 bonds with 3 carbons and 3 hydrogens, and 1 carbon. So this is a typical way of representing, this is a how do I put it, a structural representation of this compound. The third way of representing is the one we call the condensed structure. When you look at the structure we have in 2, that is the structural formula, you will see that the first carbon has 3 hydrogens. That is why in this condensed structure we have CH3. That is to tell you that that first C has 3 carbons attached to it. The second carbon in that condensed formula has 2 hydrogen. That is why we have CH2. That is to say that carbon number 2 is attached with 2 hydrogens. And the third carbon has 3 hydrogens, CH3, attached to it. So it's just like a summary of the condensed, the structural formula. In this case, you will now write each carbon and hydrogen, indicating the number of hydrogen that is supposed to be attached to each of the carbons. Then in the fourth way of representing, we call it the skeletal formula. The skeletal formula gives the shape of the compound. In this compound now, you'll be able to say that this compound looks like this or looks like that. The skeletal formula is what gives us the shape. It gives us an idea of what the shape of that compound should look like. So looking at this one, you will now see that our CH2, that is carbon number 2, takes the upper position, while carbon number 1 and 3 takes the down. That is to say that if I should use a common reasoning, you will say that carbon number 2 has 3 hydrogens. Carbon number 1 has 3 hydrogens. Carbon number 2 equally has 3 hydrogens. So this is enough. They have more hydrogen than carbon number 2. So it's enough to weigh them down. I don't know if I'm following. The carbon number 1 and carbon number 2 has more hydrogen. That is to say that they have more weight. That's why they are weighed down. So if you look at the structure, you'll now be able to see the skeletal formula. You'll now be able to see what the shape of these compounds actually look like. Finally, in this class, I would like us to look at the prefix tables for organic compounds. These prefix tables, or rather the prefix table, tells us the number of carbon atoms in the compound, which identifies the parent name of the compound. That is to say that the prefix table will tell us when we have number of carbon atoms, what it is called. When we have 1 carbon atom in a compound, what is it called? So for this class, we are going to consider carbons number 1 to 10 in the prefix table. Now let's look at the prefix table proper. If you check the first carbon, that is the number 1, we have the prefix as met. Then number of carbon 1, compound name for single bond. Single bond, we have the parent name as ane, A-N-E. That is why we have the name as methane. Then compound name for double bonds is ene, and for triple bond is iron. So you discover that when we have 1 carbon atom, the carbon has no double bond, neither does it have triple bond. So that is why we have only methane as methane. They are saturated, they belong to the saturated family of organic compounds. Maybe in a subsequent class we'll talk about saturation and unsaturated compounds. Then in carbon number 2, that is a compound that contains 2 carbon, is named, or rather the prefix is eth. And if it's a single bond that is bonding the 2 carbons, then we call them ethane. If it's a double bond, we call them ethene. If it's a triple bond, we call them ethyne. The same thing happens in carbon number 3. The prefix is prop. Then if it's being bonded by single bonds, we call them propane. Then double bonds, we call them propene. Triple bond, we call them propyne. In butane, that is but 4 carbons, we have pent, 5 carbons. The essence of this table is for us to know the parent name. For instance, when we have a compound that contains 6 carbons, remember we are told that the number of carbon determines the name, the parent name of that compound. So having seen a compound with 6 carbons, we should automatically know that the parent name should be hex. Hex, we start with hex. Then whether hexane, or hexyne, that will be depend on the number, or rather on the nature of bonding between the carbons. If we have single bonds, then we can call it hexane. If we have double bonds, we can call it hexene. If we have triple bonds, we could call it hexyne. However, these are for hexane, hexyne are for compounds that contain carbon and hydrogen alone. So I want to believe that you've been able to pick 1 or 2 things as regards to naming of an organic compound. When you have compounds to be named, the first thing that comes to your mind is how many carbon atoms are there in that compound. And when you know the number of carbon atoms, the prefix table will help you tell you the name, or rather the prefix for those number of carbon atoms present. If it's 4, for instance, you should be able to know that the name should start with but. Then the next thing you consider is the bonding between the carbons. Is it single bond? Is it double bond? Or is it triple bond? That will now help you in completing the name. If it's a single bond, you will now call it butane. If it's a double bond, you call it butene. If it's a triple bond, you call it butyne. So my dear friends out there, I believe that you've picked 1 or 2 things from today's class. I promise you that in the subsequent class, we are going to have a more detailed process. We are going to explain the process of naming. We are going to go into proper naming of these compounds so that you can see for yourselves how these compounds are being named. Thank you for watching, and God bless you.